Alrighty, so any questions? We're going to go through some more details of creating a class, something closer to the fraction class that has methods that return objects of that same type. So that may help if you're having trouble sort of wrapping your head around how you add a fraction and return a fraction from inside a fraction. Make you feel a little self-referential. Tam, did my comments on printing the ends make sense? No?
I replied to your comment over the new comment. So basically
I replied to 2 comments.
I didn't see the new one yet.
Okay.
I don't know. You probably answered that objective, but basically my original question was, say, if you selected 2 over 0 and you wanted a fraction form, should you print NaN or should you print 2 over 0?
So my question is, what do you mean by fraction form?
Fraction form like this original fraction, not 2 double. You know, just when you convert it to 2 double, you get the decimal form.
So it's a bit of a philosophical question almost. Your fraction, right, the class, really consists of 2 integers, a numerator and a denominator. It's not a fraction, it's not a double, it's not a nan, it's really just 2 numbers, right? The only time it turns into something like, you know, a bunch of digits or something with a slash or NaN, the only time it turns into something like that is exactly 2 cases. 1, when you convert to a double, and 2, when you call the toString method, right? So when you convert to a double, if it's got a 0 on the bottom, you're supposed to return NaN, double.nan. That one's pretty straightforward, right? There's no real choice there. But the toString method returns a string, and the assignment says if the number is undefined, toString should return NaN. So you just want to return that 3-character string.
Okay, so we don't need, because when I say fraction form, I'm talking about like the string numerator over denominator.
Which is the return from the toString method.
Correct. So if the user enter like 2 over 0, it should return NaN and not 2 over 0, correct?
Yeah, so if you do the following, fraction f equals new fraction 2 comma 0, and then string s equals f dot toString, s should be equal to NaN.
Okay.
Not 2/0 or 2/0 NaN.
So the other question, I can pose this later, but what if we enter a null fraction? Like say our fraction is f, what we do f dot add null.
What do you mean null? Just f dot add null?
Yeah.
That's going to give you an error.
I know, but like, what do you want us to return? Because originally I set it up to return f by itself.
You're gonna give a compiler error. We tried it.
I don't know if it'll give you a compile error, because null will actually pass as a type. But that's an exception, right? So I'm not requiring you to do anything special in that case.
Okay, because I originally just have it set up to just return f or null. So let's say like if you do 2 over 3 plus null, it's gonna return 2 over 3.
Okay, so you're actually checking the argument to see if it's null?
Yeah.
I wouldn't do that. I would leave it to the fates.
So I don't need to do any null checking.
Yeah, and I would not treat a null argument as 0, right? I would just, if somebody passes you a null argument, let it blow up.
Oh, okay.
Partly because it's probably a problem with the caller's code, right? They're probably trying to send you a fraction and they pulled it out of the wrong spot and they sent you a null instead. And it's probably better for them to get an exception in that case than to have you silently treat it as a legitimate fraction.
You could set like an invalid flag or something. That would come up later.
Yeah, to me, this is not an issue for your fraction class to deal with, though, right? Unless you have some legitimate reason for working with a null, like if you were trying to store nodes in a linked list and you wanted to be able to store a null, right? Then you might want to do something with that. but we don't really need to. Yeah, I'm gonna say don't try to police that.
So, should we do any error checking beside what's stated on the assignment page? Any, out one?
I don't think there's any errors possible,
Okay.
right? If you try to pass it with something that's not an integer, you'll get a compile error. And we've got the undefined handles, so yeah, I don't think there's any errors per se.
But we are allowed to do our own public script, right?
What do you mean?
Well, so whatever is on the assignment, all required, but we can add our own additional scripts.
You can. What are you thinking of?
No, because the way that I did the reduce function
Mm-hmm.
is kind of weird. I did a public one and a private one.
Okay.
The reason why is because I didn't want it to reduce as soon as it was created, the variable was created. I
Mhm.
wanted it to reduce as soon as you do some type of operand.
Okay.
That way, let's say when you add, in the add function, I would call the auto fraction and do the reduce from that fraction.
Okay.
Reduce from this fraction, then I add it. But I didn't want it to reduce as soon as you create a new fraction.
Okay. So you reduce when you do your add, subtract, multiply, divide.
Yeah.
Do you reduce when they call toString?
Now, because, should I?
Well, suppose I make a fraction 125, and I say s equals f dot toString. If I end up with s equals 125/25, right, that's not what we want.
Oh, okay, yeah, see, that's the thing I was confused about, like, I didn't know you wanted us to print fraction form, but I wasn't sure if you want us to print the original fraction that was entered, or the actual reduced fraction that was
Reduced. Always reduced.
Always reduced?
Yeah.
Okay. Then I don't need to call it, sure, yeah.
Okay.
You want to reduce as soon as it's created.
Yeah. If you don't reduce as soon as it's created, you can still make it work if you reduce every time that you add, subtract, multiply, divide, and do a toString. But why not just do it up front and then never have to worry about it?
Since when you're adding and subtracting and all that, since you're returning a new fraction anyway, it doesn't
Mhm.
mean it's automatically do
It'll
it?
automatically be reduced if you're reducing in the constructors. Yep. And even if you wanted to leave it unreduced, I'm not sure why you would need a public reduce method. It only has to be public if something outside the class wants to
Yeah,
call
because
it.
the reason I'm doing public is because when you do let's say you have two fractions, x and y.
Mhm.
S x dot add y, inside that add function of x, I'm calling the y reduce function.
That's okay.
Public.
It's still in the same class, so it doesn't have to be public.
Or does it?
Yeah.
Oh, okay.
So it's not public or private within an object, okay? It's within the class itself. So x and y are both fractions. They both have access to every method inside that class, even if they're calling a method from another object of that class.
Oh, okay. So private and public doesn't matter about the object, it doesn't matter about the class?
It's only about the class, yeah.
Oh, okay.
So typically if you have a main program, that's a different class. If you wanted to call the reduce method inside a fraction, that would need to be public. But yeah, from one object to another, a fraction, they have full access.
Okay, thank you.
Yeah, I should have mentioned that last week. That's a good subtle point. All right, any other questions? So I want to talk about a few things today. I want to talk about these command line arguments, the string bracket args that we have on the main program. I want to dig into that, and that'll take us a little bit into looking at arrays in Java. And along those lines, I want to talk about how we can do some parsing, how we can do something like scanf, but a whole lot easier than scanf. And I want to talk about the this keyword, and then I want to start looking at an analog to the fraction class. I think we'll play with complex numbers, and that may help illuminate some things. Oh, lab 1. Okay, so I graded lab 1, and that looked great for everybody. One general comment on the lab reports. Make sure that starting with lab 2, your report is kind of a standalone document. Okay, you can read it from beginning to end and understand exactly what you did. So don't think of it as a homework assignment. Okay, first thing I'm supposed to do is run the df command, and you say the df command returns such and such. Next thing says how many processes were on the system, and you say 80 processes, right? And so somebody picks up this report, and it says the df command reports this, 80 processes, 500 megabytes, 11 gigabytes, right? And you've got all these numbers written down, and the person's like, what the heck am I reading? Okay, it should stand by itself without knowing that this was lab 1 in 223 and digging up a copy of the assignment. You want to be able to read from beginning to end, okay? Lab 1, getting familiar with the Raspberry Pi. In this lab, we ran a series of simple commands to learn about this computer. First, we did the df command. It showed us we had this much space available. Then we checked the top command to see how many processes we had. We had 80 processes, that kind of thing. Okay, yeah?
So I tried to do the Raspberry Pi thing on my laptop, and for some reason, I changed it to everything how it was supposed to be set up, and it wouldn't log in to PuTTY, and then I don't know if I'm supposed to download something on my computer.
So you're running Windows?
Yeah.
So it should work, but it doesn't always work, right? So this is why there was a week for the lab, because there's lots of effort sometimes in getting it to connect, right? Once it connects once, you're good, right? You'll be able to do it forever, presumably.
I tried to go through CMD and stuff, and still.
You tried what?
The CMD command they said to load through.
Mode?
Yeah.
Were you able to find the device?
No.
Okay, so you may need to download and install. It's usually a CP2102 driver.
Oh, okay.
So Google CP2102 Windows driver download, and well, let's see what you get. And I think I think the VCP one didn't work for somebody though. So
Go to one of them and show you a bunch.
and I think this one works. But download that, and it's got an exe, and you run through that install, and that actually seemed to install it completely. You didn't have to go through Device Manager after that.
Thank you.
So try that, and then plug the device back in again, see if it comes up. And if you go to Device Manager, you should be able to, I don't have Device Manager on Linux, you should be able to see it under USB devices or under ports.
Yeah, like when I did through the device manager, it still was like showing the like caution sign. Like it
Yeah,
was,
yeah. So you just need to find the right driver and install that. Cool. All right, so we'll talk about Lab 2 next week. It's not due for 2 weeks. Lab 2, you'll be making an LED block though, so it's a whole lot more exciting.
Are you going to be talking about static today, or?
Nah, we'll leave static for a few weeks. It's not really relevant for what we need to do in the short term.
Yeah, so we got the Java document, like a bunch of like methods we return like static and stuff like that.
Yeah, well, we'll talk about static a little bit. I don't want it to be mysterious. All right, so here's our main program, right? And it's got one argument, which is string bracket bracket args. Okay, so string bracket bracket, that's how we say we want an array of strings. Okay, if we say something like integer bracket data, that's an array of ints. And we haven't told it how big this array is. It's like saying integer star data. Okay, we're just declaring the type of variable that data is. It's an array of ints. But we haven't said how big it is yet. Now, if we wanted to actually allocate space for it, we could say something like data equals new int bracket 100. And that actually creates a chunk of memory that'll hold 100 integers, and it sets data equal to that. But we don't have to worry about that in our main program because we're being handed an array of strings. Okay, the argument to main is this thing that we're calling args, and it presumably already points to an array of strings. It might be empty, it might be a million strings, but we don't have to allocate space for it, right? So this is like the car star star argv. It's already a pointer to it.
RB basically arc
Yeah. So let's just print it out and see what it looks like. So if I say Java main, it tells me args equals, and it's some gibberish. If I put some command line arguments on here, it's still some fairly meaningless gibberish, right? So remember, when we try to concatenate an object to a string, it turns it into something that means something, but this means something to Java internally. And how does it concatenate this array of strings to a single string?
Two-string.
It uses a toString method. Okay, anytime you concatenate an object, it calls a toString method to figure out what that thing should look like as a string. And the default toString method for an array of strings is giving us that. Okay, so let's do something different. Let's look at args. Now, args is declared to be an array of strings. Arrays have one peculiar thing to them. We don't really need to do this. When you have an array, it has a field called length. Okay, it's not a method. When we work with strings, strings come with a method called length parentheses that tell us how long the string is. But arrays always come with something like a field called length. So if data is an array, we can say data.length, and it'll tell us how big that array is. And it's a little bit asymmetric to everything else that we do with objects, but that's okay. So let's just print out args.length. So if we say Java main, args.length equals 0. If we say Java main, this is a test, args.length equals 4.
It's basically what you would want it to be.
So it's what you would want it to be, right?
Gotcha.
And if I say args.length and I say this is a test inside quotation marks, args.length is 1, because in the shell, things in quotation marks get treated as a single argument and passed as the first argument. So args.length tells us how big our array is. And if we know how big the array is, we can print out the elements of our array. So let's do that. And I'm putting in some extra text in here, but I basically just want to print out each of the args bracket I. But I'm showing us exactly which argument we're printing, and I'm throwing angle brackets around the string so that if there's spaces or new lines or non-printables like that, we'll see them by the placement of the angle brackets. So compile that up, check your syntax errors because we're not in C. So Java main, this is a test, args.length is 4, and as you would hope, each of the elements in that args array is just the next string, the stuff separated by spaces.
So we don't need to worry about the first argument being the name of
You don't need to worry about the first argument being the name of the function or the program, right? It doesn't do that. And if you go crazy with spaces, that makes no difference because when this thing is being called, remember bash is looking for things separated by spaces and it's passing each of those things as the next argument. This is the same behavior you'd get if you were just in a shell script and you were looking at $1, $2, $3. But if you do something like this, of course, right, if we put that third argument inside quotation marks with some spaces in there, then those get preserved when we pass it to whatever it is that we're passing it to, a script, a Java program, whatever, so that arg2 is that A with those spaces. So kind of the reasonable thing you'd hope would be happening here is what happens. And if we try to print too many things, so let's go up to the length plus 10. Then we get an exception. Exceptions are errors. And it's a pretty reasonable sounding exception, right? It tells us that it's in main. The type of the exception is java.language.arrayIndexOutOfBounds exception. Pretty clear what that means. This gives us a value of 2, which means we were trying to use an index 2 and that's out of bounds, and it tells us this happened at line 8 in main.java. So you come over here and you go down to line 8 and look for an array access, and there's only one, and our value of I got to be 2. And that's because we typed something weird up here. So we usually don't just get Segfault core dumped, right? Usually there's a little more information, and that's partly because this is an interpreted language. The interpreter knows what your program is trying to do. It knows the state of the environment. It knows the names of the variables and so on and so forth. So it can give us a little more help than a C executable. It just says you touched an area of memory you shouldn't. Goodbye. That's your Segfault. All right, while we're here, let's talk about efficiency a little. So I've got two windows here, right? I've got one window where I'm editing, and I've got another window where I'm compiling and running, right? Do you need that? No. You can leave the editor every time that you want to compile and run, but I can stay right exactly where I am, and I can make a change and try it, and compile that up, and if it doesn't work, I could just undo it because I'm still in my VI session, right? It's not a huge difference in time savings, but it can make your life a little easier. If you're in Unix, right, and you're running a terminal session, most of these terminal windows are tabbed. So I've got 2 tabs, and you can click on the tab heading, right? But you can also set up keyboard shortcuts. So I've got shift arrow keys that take me between my windows. So that can be a little faster. And I'm making judicious use of my recall to do my compile and my execute.
Wait, so there's an undo button? Or
A U,
U?
yeah. So U will undo, and if you undo twice on some versions of VI, it just undoes the undoes, so it's a redo. But other versions will have multiple levels of undo, and then you can do a redo to undo the undos. But yeah, that's really handy.
I can count so many times I hit Control Z reflexively
Mhm.
and undo something.
Oh, to undo something? Yeah. And if you Control Z to undo and it takes you out to like this, don't just exit or don't just VI again, right? If you try to VI again, you get the most annoying message
Yep.
in the world, right?
That's what happened.
And if you ignore that and say, yeah, I don't care, I'll just keep going, then you see this forever, right? So quit out of that. So jobs, remember, shows you what jobs you have running. Don't kill it, because that'll bring that annoying message up, right? You have a VI session running right now, and you have this .main.java.swap. That's how it knows you're in the middle of editing this file, which is why if you try to edit it again, it'll give you a warning message, because it doesn't know if it's two people going after the same file. So get back to where you were before you said Control Z, just say foreground %1 or just foreground if there's only one job. Now you're back where you were inside VI. Okay, so Control Z will throw it into the background, or we'll suspend it so that you can throw it in the background. You could also do something like this. Alright, so now I've got two single keystroke commands. If I want to compile, I can do that. If I want to run, I can do that. If I want to run with arguments, I can do that. Right? These aren't going to like make or break your day, right? But if you're compiling 80 times in a session to try to figure something out, right? It's nice not to have to break your stride and type in commands or go back with the up arrow and find your last recall and stuff like that. Little tricks like that, right? This is why you take 224, so that you can be more fluent and comfortable in a Linux environment. And this is why when we're working at the command line, which we're doing for PA1, right, it can be useful to do those things. When we switch to Eclipse, right, then all this goes out the window, but you're still on the command line for your labs. So little tricks you make for yourself will help.
I know that the exclamation mark Java C.
Yeah,
Yeah,
but you got to type Java C, right? Because Java and Java C start with the same first 4 letters.
That's true.
So you can't just do exclamation J.
If you're working with more than one. No, because Java C also looks at all the other classes main depends on. So
Yeah.
it works anyway.
So it's not the worst problem in the world, but
That's one thing that's different from C.
yeah.
That compiler.
If you want, you also make a main file.
You can. Totally. All right, so let's go back to our rectangle class. So our rectangle class, we had 2 variables, height and width, they were doubles. And in our constructor, we said rectangle, I'm going to pass 2 arguments. I called them h and w. And I said set the height equal to h, set the width equal to w. Okay, why did I call them h and w? Because I'm already using the words height and width. And if I tried to call this something like height and something like width, then my statement becomes something like this. And that's silly, right? Because once I have an argument to my rectangle constructor named height, height is a local variable within this context. Right? So inside, between these curly brackets, if I use the symbol height, it means this thing right here. And when I say height equals height, I'm really just setting this thing equal to itself. What I really want to do is set this height up here equal to the argument height. Right? Which is why I originally named this argument something different from height. I just called it h. So there's a really convenient way to say, I want to access this height up here, this one from the class, and it's just the keyword this.
I actually had some like this pattern when I was training the red regular expressions and renaming my variables.
Uh-huh.
Yeah,
And it went a little crazy.
Yeah, it gave me a no pointer exception.
Mm-hmm. So what's really going on here, though, is that this is a synonym for, okay, from the mind of an object, this is a synonym for myself. Okay, so we've got to get a little youngish here. So let's say we have rectangle R1, and we say R1 dot something. Let's say we call a method, right? Inside this method, this is a synonym for R1. If I have another rectangle R2 and I say like R2 dot area, inside this method, this refers to R2. Okay, it refers to whatever object it's currently is. It's hard to talk about self. Yeah, it's me if I'm this. So this actually refers to the particular instance of rectangle, and so this dot height is saying let's look at the height field in this object, and that's this variable up here, as opposed to just height, which happens to be a local variable here. And this is nice because if we really want to call this thing height, H-E-I-G-H-T, we don't have to give it a different name in the argument. We can just say height and set it equal to this dot height. So you'll see this kind of notation a lot, right? Especially in constructors, but also other places. All right, is that clear? All right, so let's make a complex number class. So what do we want with complex numbers? So what is a complex number? It's a thing with a real and imaginary part, right? So what's an imaginary number mean?
A number that doesn't really exist.
Doesn't really exist.
Like
Not like negatives that
square root of
really
negative one.
exist.
Okay.
So yeah, square root of -1, right? So
Where am I able to see? Yeah.
it's imaginary because it's not a real number, right? If you're an engineer, you use J because I is current. So I is square root of -1, and if we write a number like A plus B times I, where A and B are real numbers, 215, then this is a complex number, right? And so funny looking C is a set of all complex numbers. And it's a useful field to work over because, oh man, you missed my beautiful,
Yes, we do.
yeah. Okay, so I is the square root of -1, A plus BI is a general complex number where A and B are real numbers. Okay, and the set of all things in this form, we call that C. It's the set of complex numbers. And the reason complex numbers are nice is because if you write a polynomial of degree 2 with complex coefficients, it always has 2 roots. And that's not true with reals. If we write a real equation like x squared plus 1 equals 0, there's no solutions to that. Okay, with complex numbers, you always have solutions, and if it's a degree 2 polynomial, you always have 2 solutions. If it's a degree 10 polynomial, you always have 10 solutions, guaranteed. Okay, so this is like, in some sense, the best place to do math. So suppose we want to add complex numbers to Java. We want to be able to add, subtract, multiply, and divide complex numbers, print them out, and so on and so forth. So we're going to make a class called complex. And to store a complex number, well, we can't store complex numbers directly in Java. We have integers and reals and doubles and characters and stuff, but not complexes. But to deal with a complex number, all we need to know is what the value of A and B are. And so A is the real part, and B is called the imaginary part. So we can do something like this. A complex number will simply be a pair of doubles, one called real, RE, and the other called imaginary, IMAG. And this is similar to what we're doing with fractions, right? We're taking the idea of a fraction and reducing it to just a pair of integers. So here's a class of complex numbers. All right, I don't think real's a reserved word. So that's all we need to store a complex number, right? So let's make a constructor. So let's make a main method. So here's the number 2 plus 2i. Right, it's a new complex 2 comma 2. If I make a complex number 0 comma 1, the real part 0, the imaginary part is 1, that's just the number I, right? 0 plus 1 times I, that's just I, that's the square root of minus 1.
Square root of minus 1, square root of I.
I'll take the square root of I. It's a fourth root of minus 1. All right. Did I close out my cheese? I did. All right, so let's print these out. So what's this gonna do? C3 will probably give me an error. So here it's saving me from myself because it tells me that C3 hasn't been initialized. So we'll take that out for now. So run Java main, and C1 and C2 are just instances of this complex class. Okay, not too exciting. So we want to be able to print these out. we'll add a two-string method so we can turn these things into strings. So you got to make this public. Call it toString, no arguments.
Don't we want this inside of the complex?
Yeah, we do. I did this last time too. Okay. So toString will just return the real part, and then a plus sign, then the imaginary part, and then the letter I.
You make sure it's returning a string. I think your two strings transfer or yeah, it's public two
Yeah. That's better. Thank you. Good catch. All right, so C1 equals 1.0 plus 2.0 I. C2 equals 0.0 plus 1.0 I. And we could play with the toString method to do a little better job on the formatting here, just like with fractions. If we have a 1 on the denominator, we don't usually say something /1, we suppress the /1. We could do the same thing here. If the real part is 0, we could just print the imaginary part, and vice versa. But we'll leave this as this is for now. So what I want to do is look at a multiply method. Okay, because if you can multiply complex numbers, you can multiply fractions, right? The mechanics of how you create this new object and return it, that's what I want to make sure we demystify. So mathematically, we can just FOIL these. And we get that. And I squared is -1. And we can combine things with and without I together. And so we can find the real and imaginary parts of the product. Okay, again, just like we do with a fraction, we find what the numerator and denominator of the product is, and we can use that to create a new fraction. So let's make a multiply method. All right, so what do we want to do? Well, we want to take A times C, subtract B times D. That's going to give us our real part. Well, what does this mean? So we're inside let me call this num2. Okay, we want the real part of the number that we're trying to multiply, and we want to multiply that by the real part of the number we're multiplying by. So since we're calling this mul method as a method that's part of some complex object, right? That complex object has a real part. It's just this dot real. And the thing we're multiplying by, num2, also has a real part. That's num2 dot real. And we want to subtract this dot imaginary times num2 dot imaginary. That's one of the two kind of subtle aspects of this. And then this will be, you know, this dot imaginary times num2 dot real, and this dot real times num2 dot imaginary. So don't worry about the algebraic details, right? We're just after mechanics here. So, and we can do all that on one line, right? So this dot real times, and let me change the argument name to num2. Okay, so that's the real part, and this dot imaginary times num2 dot real minus
Are you on the imaginary part now?
yeah.
So we also need the
We need
two
the other.
imaginaries.
Right.
That's by the other.
All right, so I'll be nice. We'll call these things something. So new imaginary part is going to be this dot imaginary times num2 dot real plus this dot real times num2 dot imaginary.
You need dots for num2. I'm kind of things
Yeah.
multiple.
You just return a new constructed complex number.
Yeah, so you construct a new
Yeah. All right, so like I say, not getting bogged down on the algebra, right? This is the real and imaginary part of the number that I want to return, right? We're taking a complex object, we're multiplying it by num2, which is another complex. We want to create a new complex object with this real part and this imaginary part. And how do we create a complex object? Use the constructor. And let's be needlessly long-winded. So complex return value equals new complex. So we construct this new complex object, and then we return that. And there's a multiply routine. And we can do that in a single line. We could return new complex parentheses, first expression, comma, second expression. Right, but this is what we're doing. And we're just using the machinery inside the complex class to create a new complex number comprised of the pieces of this object's parts and the argument num2's parts. I don't know if this will compile in 2 minutes. Shocking. So let's use this. So let's set C3 equal to C1 times C2. So C1 is 2 plus I, C2 is just I, C3 is negative 2 plus 2I, which if you do the math, right, 2 times I becomes 2I, and 2I times I becomes 2I squared, which is negative 2. So that's giving you the right thing. And just one more quick check. Let's take C2 and multiply it by itself. So C2 is I multiplied by itself. Should just give us minus 1. And that's what it gives us in the bottom there. C3 is minus 1 plus 0I. So I'll stick this code on the code site linked to through Canvas. But if you can make sense of this, particularly this multiply method, right, you should be able to do the mechanics similarly for the fraction class. For add, subtract, multiply, divide, and there's a sample 2 string in here also. So hopefully that helps. All right, cool. I will see you next time.